Hello, everyone. Welcome to my session. You hold the keys to the kingdom. Developers under attack. My name is Fabio Viggiani. I'm the technical lead of penetration testing at TrueSec. And today I'm here to scare you a little bit. So as a penetration tester, if you're not familiar with the concept of penetration testing, what that is basically trying to assess the security of a system or application or IT environment in general by trying to break into it at first and then see what's possible to do once we're in. So we replicate what real attacks would do, and they normally involve different steps. They start by the attackers will try to take some sort of foothold, find an entry point into their target organization or environment, and then they will try to expand and escalate their privileges. So this process of escalation can be done in different ways, but once you have a foothold in your target organization, then it's usually a matter of finding out what's around you and what type of internal applications you can access. And it is very interesting for attackers to come across accounts that have access to certain types of applications, and developers are a great example of a category of users that have access to applications that attackers can leverage and exploit to access further resources in the network. So what I'm going to do today is give you an example of an attack that involves leveraging what a developer account has access to in a certain organization. And this is the objective of this session is to show you one way of doing it and basically raise awareness in what user behavior and how it can make a difference. This is a demo-based session, so I almost have no slides, just a demo. I'm gonna get right to it. I just want to start by talking about what a regular or a standard attack looks like nowadays. Let's take an example of a classic IT environment that includes a Windows domain, like most organizations do. And so what will happen is that the attackers will try to somehow find an entry point, get into your environment. And normally, we can categorize types of entry points in three areas, roughly, which would be internet-facing, client-side, and physical. So internet-facing has to do with vulnerabilities in applications or services that are exposed directly on the internet. So your public websites or mail servers or VPN servers or whatever is exposed directly to potential attackers on the internet that could exploit those services. And client-side, well, client-side attacks are increasingly common. So phishing attacks, sending an email with a malicious attachment, or tricking somehow a user into downloading and running software or malicious software, and so on. And then, of course, we can always physically walk into the building and take our device and plug it into the network. That's not something you want to start with normally as an attacker, because you would expose yourself physically. So once we gain a foothold, then we'll try to expand. And if we talk about Windows domains, that usually is equivalent to gaining domain administrator privileges. So compromising a domain admin account in some way. Once we do that, then we'll try to pinpoint our final target. That target changes depending on the organization we are attacking. So if it's a bank, that could be their mainframe where all the transactions occur. If it's a law firm, it can be their internal database with all the customer data and so on. So that changes. And it's usually not part of the Windows domain, but it is, in almost all cases, directly or indirectly accessed from machines that are part of that domain. So once you own the entire domain, then it's just a matter of finding the right machine. So you can either install a keylogger and find the credentials to reach your target, or just still store credentials on that system, or, well, it's pretty much up to your imagination. But there is a dependency between the domain and everything that is accessed from the domain. So I will use the client-side attack to compromise a user account. But I won't do that by sending an email. We'll do it in a slightly different way. So let's begin with our demo. We will be that attacker up there on the top left, and we will target a user in our target organization. It's called Bobby Tables. You may have heard of him before. So this time, Bobby Tables will post a question on a public site related to something that he's trying to figure out as a developer. So something like Stack Overflow or similar sites where you can post a question. So let's take, this is Bobby Tables' workstation. And he just posted a question here because he's developing some sort of web service and he needs a client that is supposed to be part of the Visual Studio installation directory, but it doesn't find it. So he just posted a question asking where he can find it. And the attacker on the other side, well, we'll see that Bobby Tables posted that question, and we'll use that fact by trying to trick him into do something. So he will answer with something like, "Hello, Bobby Tables. Yeah, it's a common issue. You can simply solve it by downloading this software from here and run it. And here's the link that points to don'ttrustme.truesec.com, tools, Microsoft, blah, blah, blah." And Bobby Tables says, "Yay, well, that will probably solve my problem. And I'm just a regular user with no particular access in this organization, so, you know, how bad can that go?" So if I'm the attacker and I want to make a victim run something on their computer, what do I run? Well, it depends, of course, on what I want to do, but I normally don't just want to run something and be done with it. I want to have some sort of access as the attacker, some sort of interactive access to that system, so I can do things as I want, as I go further in my attack. So the attacker will host that file on his own web server. Let's see what I have, so we can take a look at it. So this is the WCF test client. It's an executable. If we open it, this is actually a self-extracting archive that contains two files. One is the actual web service test client from Microsoft. And there are an additional 253 bytes which will start something which I'm going to talk about in a second. So as an attacker, I'm running code, or I'm attempting to run code on a victim. So I want to do what's called opening a reverse shell. So since that system will be somewhere on the internal network, I need that system to make a connection outgoing to the internet, to the attacker machine that will be listening for an infected client to connect. And by doing that, the client will open a channel that will allow the attacker to remotely control that computer. Now, we don't need to go into all the details about how that's done. That's not really the point of this session, but I'm going to show you the effect of it. So this is what the attacker will do. I'm going to use the Metasploit framework. I'm sure most of you have heard of it. It's a free-to-use framework for exploit development and execution, and there are all sorts of modules you can use. So I will use this now to listen for infected clients that will connect to me. So what I'm going to do is configure it to wait for a certain payload, which I'm going to talk about in a second. This payload will connect over HTTPS. So this client will make an HTTPS connection to the attacker system, which will be listening on a certain IP address on a certain port. That's pretty much what this is saying. So we're going to configure our listener, and we're now listening on port 443. Now, the client needs to, well, run something specific. It needs to run a certain payload. Now I'm using something called Meterpreter. It's a certain agent that's already part of the Metasploit framework. It's an agent that has a lot of built-in functionality that we're going to see that is very nice. But if you look in our file that we're executing, well, the only executable here is the actual real web service client. So the way we're going to run Meterpreter is by downloading it on the fly, in this case using a PowerShell command in the background. So what we're doing is invoking net.webClient, download string. We're downloading something else from the attacker's site called Invoke Shellcode. This is a PowerShell function. Now we're using something in PowerShell called IEX, or invoke expression. That is a extremely useful feature for an attacker because this will interpret inline whatever is passed to it, in this case the text downloaded from that file, and it will be interpreted by the PowerShell process in memory. After that, we can call whatever function was defined in there. Now that one will never be written on disk, so the antivirus will never look at it, which is a very nice feature for an attacker. Also because if you put a straight Meterpreter payload on any computer nowadays, most of them will go crazy with the antivirus. So you don't really want to do that. So either you obfuscate and then put an executable there, or use a technique like this one. Anyways, this invoke shellcode contains functionality that includes Meterpreter, so we just tell it where and how to connect. Reverse HTTPS on the attacker machine on a certain port. So let's see the effect of this. I am listening. Now Bobby Tables will be happy to see that response, will be happy to follow that link, save that file, waiting for the antivirus to fail its checks, and then run it. And Bobby Tables will not really bother about the fact that the publisher couldn't be verified. It's going to click run anyways. And all the actual web service client will pop up, except something else happened in the background. So now if we go on the attacker side, we have a connection incoming. Meterpreter session open. I can list my sessions right now. I can see I have a session that came from a machine called client01 in a user context of the user Bobby Tables in the etarip domain, coming from this IP address. So what happened is that after Bobby Tables ran the software or malware, I now have a established interactive channel, a Meterpreter channel to that system. What this means is that now from this Meterpreter channel, I can interact with that. And well, there are many built-in Meterpreter commands, but the simple thing I can do is just open up a regular Windows command prompt. So that's a Windows command prompt on Bobby Tables' computer. So I can do, I don't know, hostname, who am I? All right. So what's the next step? Well, I now have an entry point. Well, I found an entry point. I have a foothold in the environment. I'm obviously in the user context of Bobby Tables. What does that mean? What can I do from there? Well, I don't know that yet, so we're going to find out. I know that I'm in a domain called etarip. Let's do an ipconfig/all. See some more information. We can see that full name is internal@derib.com. I have an adapter on this network. I could try and look for other systems. But first, I want to see what type of privileges I have as the user that I currently compromised. So let's see who Bobby Tables is in the domain. So let's do a net user bobby.tables/domain. So I want to check my group memberships in the domain, and I can see that I'm just a regular domain user, no special privileges whatsoever. What about locally? Am I a local administrator on this computer? Can I install additional software and so on? Well, let's see. You can do net local group administrators. So the local administrator on this computer are two local users called admin and administrator, and the domain users in the domain admins group. But Bobby Tables is not in that group and is not one of these accounts. So he's not a local admin. So this is good for Bobby Tables. Low privileges. There are still a lot of things we can do. Because Bobby Tables is a developer, and he has access to a lot of interesting functions in that organization as a developer. I will show you an example of something that we've actually used several times during penetration tests, even of organizations with high security requirements. This is a very effective method to go. So Bobby Tables, among other things, will be able to reach the internal Jenkins server, Jenkins application. I'm sure most of you know about Jenkins, continuous integration tool. Why is that interesting? Well, an attacker could attempt to misuse it, and I'll show you exactly how. So this we can close. The interpreter is running in the background anyways. So on this address, internal IP address, we have the Jenkins server right here. So the attacker can try to find that address. I mean, he can look at connection from that machine. He can search for other systems in the networks and so on. We're going to skip through that part. So how can the attacker try and make a web request to the Jenkins internal application from Bobby Tables workstation? Well, one nice way, simple way, is to use PowerShell. You can make a web request, invoke web request, pass in the URI. Now I'm going to go to /script, and I'll show you why. Let's try to make this call first. I got an arrow back. Authentication required. Well, I'm not providing any authentication now. So, okay. But Bobby Tables will access that application. So what happens when Bobby writes his username and password here? And logs on. Where are these credentials stored? Are they stored anywhere? Where are they? In a cookie. Yeah, most likely. I mean, definitely in this case, but if you access the web application, you authenticate, in most cases, you will have an authenticated session, and the session ID will be stored in a cookie. Where is the cookie? Well, it depends on the browser you use, how that's stored. So there are many ways we can go about trying to find it. But I mean, in this case, the Firefox process, that's in the user context. Bobby Tables started the browser, so he has control of that process and everything happening in it. So how about we look directly into the memory of that process? At some point, those cookies will be passing there. So once again, I'm going to use PowerShell to make a memory dump of the Firefox process on the infected client. So that's not a built-in functionality. I need additional tools. So I'm going to use once again the same technique of downloading an additional PowerShell function called outMiniDump, pass into the evoke expression, and in memory call it. So first I'm going to call getProcessFirefox and pipe that to our new important function outMiniDump. And I can store this directly in our current directory. All right, so that's my file. Let's do a directory listing again. That's our memory dump file. It's an almost 400 megabytes. It's a full memory dump. So, well, we could upload other tools and do the memory analysis over there, but it's nicer to just download the dump file on our attacker machine and analyze it locally. So let's do that. So one of the nice things with the Meterpreter is all the built-in functions, like, for example, download and upload files. So if I exit the Windows command prompt, I go back to my Meterpreter command console. I just need the name here. I'm gonna, oops, all right, there we go. I'm gonna start downloading that file. Put it on my desktop in a folder called procdump. So let's go there. Now it's gonna take a little while. Did I do something wrong? Do you see any? Let's see if I can still run in commands. Oh, this is all local. Well, my Meterpreter session died, obviously. I mean, that can happen. So we'll shut it down and we'll redo it. One of the first things you should do if you're not in a demo is to try and get persistent before you start doing stuff. So if this happens, you still have a shell. So let's see if we're still listening. And yeah, something happened, obviously. So let's run that again. All right, we're back. All right, let's do that again. And let's do that again. This is very unstable today. Okay, This is growing now. Looks better. All right, so let's look for a cookie now. Well, that cookie will be set by the web server using a set cookie header. So let's look for that. So we're just doing strings on the dump file. Maybe call it. And looking for set cookie and taking 2 rows before and after. All right, we're getting something. All right, and there's the Jenkins cookie. So let's use it. We're going to do an authenticator request. We're going to call PowerShell again. This time, instead of just doing a regular invoke web request, we're going to pass it a session, which is defined by setting this cookie. We just need to make sure we use the current authenticated session. Try this again. All right, that's better. No exception anymore. We got back an object that is the actual HTML response object that contains the HTML response. So now we're successfully authenticated to Jenkins, and we're browsing that through Bobby Table's infected workstation. All right, why did I go to the script functionality or to the /script part of the site? Well, Jenkins has a great function. If you go to /script, there is a script console where you can type in an arbitrary Groovy script and execute it on the server. Useful for troubleshooting and diagnostics, and for attackers. So, well, what I can do is invoke in system commands from my Groovy script. Do something like this. cmd/c ipconfig.execute. We'll run it on the system. Let's do that from here, show you how it looks like. We click on run. And the output is the output of the ipconfig. How nice is that? All right, so let's do that as attackers now. I'm going to, let's see. Let's take this. I have a few commands using the cookie, so I'm just going to do a global search replace. I should do it. So I'm going to invoke the same request. This time I am passing body parameters, which are defined as print cmd ipconfig execute.text. So that's my Groovy script executing ipconfig on the system, and putting the output file in a file called response.html. So let's do that. That's my HTML file. So let's type it. Oh, yeah, that was just the end of it. It actually starts up here. Right, and at some point, I have the output of the command, the output of the ipconfig. So I am executing commands on the Jenkins server through Bobby Table's computer now, using his stolen cookie. But this is not very user-friendly. I mean, yeah, sure, we can run code, but we need to put it in this PowerShell command and download the response and parse out the result. So I wrote a small PowerShell function that does that directly or automatically. well, I mean, it doesn't do anything special really. I call it Invoke Jenkins command. It basically takes parameters, URL, command, cookie name, cookie value, and it execute exactly what we saw, put it in a HTML response, and parse out the result, and print out just the output part of the command. So nothing special, just make it a bit simpler. Of course, that's not part of functionality of the imported modules in PowerShell on Bobby table, so we need to download it again. So we're going to use the same technique that we have used before. Download string, invoke Jenkins command. We pass that to invoke expression, and then we can call the invoke Jenkins command function, passing parameters URL, the command we want to run, and what cookie we're going to use. I think I got the wrong cookie for some reason. That search replace didn't work very well. That's right. There we go. So now it's clean output of just the command I'm running. So if I want to run something else, I just run it here. And I want to do a task list on Jenkins. Do it here. That's a task list output from Jenkins. So if I do who am I here, what identity do you think I will have? Administrator? Why? Under what context am I going to run? Jenkins user, that's right. So whatever identity the Jenkins process or service is using will be my identity now, because that's Jenkins running commands. And well, if you install Jenkins on Windows by default, that's local system, which is the highest local authority. Let's verify that. That's right, I'm local system. So, again, this is not very user-friendly. I mean, I'm running code, yeah, sure, but I want to be interactive on Jenkins. So what am I going to do? Well, exactly as I did for Bobby Table's workstation, I want to make Jenkins download the interpreter agent and connect to the attacker machine. So that's the command I want to run on Jenkins, right? Just PowerShell, and we download the invoke shell code, and then we call it telling to connect here, just like Bobby Table's computer did. But now we need to run that on Jenkins through our invoke Jenkins function. So another nice thing in PowerShell is that you can base64 encode your command and pass it with the -encoded command option. So that's just the encoding in base64 of this one. And then we need to run that through the Jenkins command from Bobby Table's computer. So we call invoke Jenkins command, and we pass that PowerShell command as command to invoke Jenkins. Thank you. Did it change? 835. 835. This looks right. Yeah, it didn't work for the other one. I don't know. There was some other character in it, in the, I'm not sure, demo ghosts. Right. So let's run that. Now, if this goes through, Jenkins will download Meterpreter and run it and connect to my Meterpreter listener on the attacker. And there you go. I have a new Meterpreter session. So let's background the current one. And if I list my sessions, I now have 2 sessions, one from client 01 and one from server 01. That's Jenkins server. And I have the system identity now. Right? So Jenkins is red as well. It's compromised, and I have an interactive shell on it. Now I'm local system. I'm not low privileged on that system anymore. All right, what's the last step? Or, I mean, last in this demo, what's the next step? Well, as I said, we want to compromise the entire Windows domain. Now, I am local system on a domain joined computer. So I'm going to use a type of dependency that we use all the time when we escalate in Windows environments. And it's the fact that when you log on with a domain account to a domain joined system, you carry your credentials with you. So you're going to expose your credentials on the system where you log on to. So any local administrator or local system on that remote system will be able to extract the credentials of all the users that are currently logged on to that system. That makes a huge dependency, because if you think that, for example, I'm a domain administrator and I'm remoting into Jenkins for administration, whoever is local admin or local system on Jenkins can steal my domain admin credentials. That's just the way it is. That's just because of how single sign-on works. All right, so normally that's done in different steps. So your local system on your machine, you extract the credentials from there, you see what you get, you use them to access other systems until you eventually grab the domain admin credentials. And in large environments, this is usually 1, maximum 2 or 3 steps until you get domain admin. So let's make a domain administrator logging on to Jenkins. Now this will be the domain controller. Now the domain admin has a RDP connection to server 01. That's Jenkins. Where am I? Here. So let's interact with session 2. That's Jenkins. So thank you very much. Session 3 is Jenkins. Let's do get UID. All right, I'm system. Okay, so if I do PS for listing the processes on the Jenkins server, I can see all the processes and the identity under which they are running. Now, since there is domain admin logged on here, there will be processes running under the identity of the domain admin. So I can either steal the credentials that the domain admin carried on to the system by looking into the else's process. So we could take a memory dump of the else's process and then use tools offline like Mimikatz to extract credentials. Or if we have an interpreter session, there is a much simpler way to do it. If we have actual running processes that we can jump to, there is a built-in functionality in interpreter called migrate that can migrate your current Aegis session into any other process on that system. So let's say I'm going to migrate to a process owned by the domain administrator by passing the PID 2300. That's the explorer process of the domain administrator. Now, interpreter will nicely do that for me. Let's get a shell. If I do who am I now, I just became the domain administrator because I'm running in the context of the process I just migrated to, which is authenticated as domain admin for single sign-on purposes. So just to prove this, let's do a directory listing on the admin $share of the domain controller. I can do that, so I'm obviously domain admin. Which means I can administer the entire domain and then jump to any other system in that domain, pinpoint my final target, go on the system that is used to reach my final target, and then reach it myself. So that's how it usually goes down, and that was one example of one application that I'm sure a lot of you guys have access to and probably didn't know there is this nice functionality that can just allow you to take over the server entirely. So what happened, really, if we look back? We compromised the Bobby Table's user account. It was low privilege, but there was a logon to the Jenkins server using local Jenkins credentials, but they were in the context of that user. So we stole the cookie. We used it to access Jenkins. We took over Jenkins, and there was domain admin, and we took over the entire domain. So this whole chain of dependencies, the entire domain is dependent on any machine where domain admin is logged on. Any system is dependent on the applications running on it, which in turn makes it dependent on all the users that have access to it and what functions they have access to, which in turn makes it dependent on all the clients that are used to log on to, in this case, Jenkins. So suddenly the entire domain is dependent on all those clients, even from a low privileged account. And if you imagine that in our networks we have hundreds or thousands of applications, it can happen with everything. How do you keep track of all these dependencies? Unless you know exactly what you're looking for and you do it consistently and methodically throughout your entire environment, which is a tedious job, then, well, it's really hard. So there are many things we can do to mitigate this, and that's stuff we talk about all the time. But ultimately, it's really the user behavior that defines how secure your environment is. I mean, at the end of the day, you can have the most secure environment in the world, but if the users do stupid things, you will get hacked anyways. That's just the way it is. So you might have more access than you think. And it's only when we understand what we really have that we start changing our behavior as users. Because I'm pretty sure that Bobby Tables would think twice about downloading and executing that file from an untrusted source if he knew what an attacker could have done from his low privileged user account on his client. So I think awareness is the key to adopting a security mindset. And well, I hope this session will be a part of that process for you guys too. So that was it from me. Thank you very much.